Hi everyone. This is a sort of follow-up video for Math 341 in class on the first day, just to kind of show something interesting involving square roots. I went through this example and I want to talk through it. I've got it written up here in better than the chicken scratch that was on the screen during class. And so this will just make a record of it. Okay, so what was the square root of I was actually the question. And it's probably relying on some mathematical knowledge that most of you haven't seen yet, though some of you may if you take more geometry or more complex analysis. So the idea is to use the complex plane and use some things that we know about the geometry of complex numbers to figure this out. So the complex plane is just like, sometimes it's called C2, and you've got an x-axis, which we call the real axis, and you've got an imaginary axis, the y-axis, we call the imaginary axis. And the idea is that every point in the plane is the point AB, where, I didn't write it here, but A and B are both real numbers. And then every point in the plane is the point Z equals A plus BI. So basically, if I went out 2 and then up 1, this here would be the point 2 plus 1i, or 2 plus I, right? Whereas, say I went down 1 over 2 here, this would be the point minus 2 minus 1i. Okay, so all this, the origin, notice, is 0 plus 0i. Why these are imaginary and real axes is, you notice anything along here, the real part is going to be 0. It's going to be 0 plus b times I. So it's just going to be a multiple of I, or a purely imaginary number. And everything on the x-axis is going to be of the form a plus 0i. And 0 times I is just 0, so the numbers on the x-axis are just going to be the real numbers. Okay, so in particular, the number I is the number 0 plus I, or 0 plus 1 times I, and it's at that point right there. Okay, note that that point is a distance 1 away from the origin, so it lies on the unit circle. So the unit circle in the complex plane crosses the axes at 1, I, minus 1, and minus I. Okay, and we use this fact. So any number here in the complex plane, we can represent it as A plus BI, but there's a couple other sort of, it's kind of like polar coordinates. There's another way to think about it. You can think about each number by how far away is it from the origin. That's called the argument, and that distance actually winds up, by the Pythagorean theorem, it winds up being the square root of a squared plus b squared, which is kind of cool. It's always a real number. And then, you can think about what's the angle between the number and the positive real axis. So in other words, if I did this, if I made a ray, a 45-degree ray, or a ray where the angle in radians is pi over 4, and had that ray intersect the unit circle, I'd get some point here. And I claim that that point is going to be the square root of I. And the reason I know that is a couple things about the geometry of complex numbers. When you do a product in complex arithmetic, you can visualize it geometrically by you multiply the two arguments together and you add the two angles together. Like, let's show, for example, that I squared equals minus 1. So I has an argument of 1, and the angle here is 90 degrees, like pi over 2. So if I multiply I by I, what I have to do is multiply the argument 1 by itself. 1 times 1 is still 1. And I have to add the angle, 90 degree plus another 90 degree. So I squared is actually negative 1. Kind of cool, huh? Let's show that negative 1 squared is actually 1. So the argument for negative 1 is 1. It's the distance 1 from the origin. And the angle for negative 1 is 180, right? So if I do a negative 1 times negative 1, I have to do 1 times 1, that's 1. And I have to add 180 to itself, another 180. So it's 1 times 1 is 0. So there's this cool sort of geometry of the product of two complex numbers, where they're sort of rotating around the origin, and because on the unit circle the argument's always 1, then it just stays on the unit circle. If the number wasn't on the unit circle, it would either move farther away or closer, you know, if you multiplied it by some other number. Okay, so because of that, this number here, the angle is pi over 4, and I'm going to square it, so multiply it by itself. Pi over 4 plus another pi over 4 is going to be pi over 2, 90 degrees. And it's on the unit circle, so its argument is 1. So when you multiply 1 by itself, again, it's 1. So that's why this number here, when I square it, it's going to be I. So whatever the number this is, that number squared is going to be I, is what I know geometrically. Now, what is that number? Well, let's look down here. That's the intersection of the unit circle with this ray. And so the ray has angle pi over 4. It's on the unit circle, so the hypotenuse of this triangle, right? If we make drop down the perpendicular to the real axis and make a right triangle here, the hypotenuse will be 1 because it's on a unit circle, and this is for pi over 4, so this is also going to be pi over 4. So we're going to have an isosceles right triangle. So if I think about it as A plus BI, B is going to equal A. It's isosceles because it's 45, 45, 90. So we've got that triangle here where both sides are, both of the small sides are A. And it's a right triangle, so we use the Pythagorean theorem to figure out what A has to be. A squared plus A squared has to equal the hypotenuse squared, which is 1. So A squared plus A squared equals 1 squared, 2A squared equals 1, A squared equals a half, and A equals 1 over the square root of 2. So that's A, and notice B is the same as A. So that point is the number Z equals, the real part is 1 over the square root of 2, and the imaginary part is 1 over the square root of 2 times I. So that, I claim, is the answer. That's the square root of I. So let's check it. In order to check it, I'm going to use just the fact that I can actually factor out the 1 over square root of 2. So rewrite using just factoring, rewrite that Z is 1 over the square root of 2 times the quantity 1 plus I, or even think about it this way as a single fraction. 1 plus I all over the square root of 2. Okay, why is that the square root of I? Well, let's square it. If you take this number and you square it, then the square of square root of 2 is just 2, and on the top you've got to use FOIL to square 1 plus I. Well, first this is 1, and then inside and outside are the same. They're both I, so I plus I is 2I, and the last is I times itself, I squared. Now I squared is negative 1, so substitute that, and then cancel off the 1s. So you get 2I over 2, and now you can cancel off the 2's and you just get I. So we proved it. So this is kind of really cute that the square root of I is actually this complex number 1 plus the square root of, 1 plus I all over the square root of 2. Whew. Now, I'm not going to assign it any homework on this right now. Maybe later on we can explore this more, or maybe some of you might want to explore the complex plane as your project. So sometimes I'll just give kind of interesting things like this, and some of them will explore further, some of them we won't. And the idea there is just kind of to let you sort of open the door and look into some interesting things about geometry, and also to give some of you ideas of things that you might want to kind of pursue in your project. Okay, thank you.